everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the LangGraph state schemas. Now, we have seen about what exactly a state, how we can define a state. We have seen a way to define the state. But there are multiple ways through which you can define the state. We call it something as schema. A state, the structure of that particular state is nothing but the schema. That structure we are going to study in this particular video. So I have created a notebook over here. In this, we'll be exploring three different types of state schemas that we can use simply in LangGraph. Out of which the very first TypedDict we already have seen in our previous videos, but still, just to revise, we can have a look at it in this particular video also. So to demonstrate these three schemas, I'll be creating three nodes that will modify the state values, and also it will observe how the state evolves differently with each and every schema that we are going to study. So first, I have just simply imported the necessary libraries over here. So as and when we use these libraries, we'll be seeing how we imported it. Okay, so let's jump into the very first type, that is TypedDict state schema. So over here you can see first we have created this state schema with the help of TypedDict. So how we can define that? It's very simple. We just have to write class and the name of the schema, or I would say the state. We have to extend the TypedDict to this particular class as we have seen previously, and TypedDict can be imported from typing extensions. And inside this we just have created two things. First is the user state variable, and second is the status state variable. Both of them are going to be string data type. Then we have simply defined these nodes. The very first node is typed node 1, which is extending this particular state that we have created. So basically this state variable is nothing but this particular state that we have defined. In this we just have created a print statement which prints typed node 1, and it returns the updated dictionary. That is nothing but it is going to update the state. Now from the state, it is updating the user variable with the state of user, that is the initial whatever value we get from the query, whatever user will put, that initial value it will take from the state itself, and it will simply add an updated value to it. That means this particular string, whatever was previously present, it will now be having a updated name concatenated with it. That's it. That is the use of this particular node. Now we are defining another node, that is status happy. Now again it is extending the state. In this we are printing the typed node 2, and here we are keeping the status as active. So basically we are updating the state variable status to active. Next we have the status sad. In this we have printed the type node 3, and then we have returned the updated state. That is nothing but the status variable has changed to inactive once this particular node is reached. Next, what we are going to be doing is we are going to define a function which will decide where to route. In one of the previous videos, we have seen routing. There I have explained you nicely what exactly is the use of routing and how we can define multiple ways of routing in LangGraph. So over here, I have created a function named random decision, which extends the state, and the return type of it is nothing but a literal. Basically, this decides whether to go on the typed node 2 or to the typed node 3. So these are nothing but the return types of it. You can simply define it just to have a check on the function. Now in this function, it simply returns typed node 2 if the random.random, that is nothing but from the random library, we are going to import the random function. This random function will simply choose a value randomly and will check whether that value is lesser than 0.5. If it is lesser than 0.5, then it will simply go to the node 2. If not, then it will go to the else part. That means it is going to go into the node type node 3. Simple as that. Here we are just checking the random value is greater than or less than 0.5. It is, if it is lesser than 0.5, then it will simply go to the node 2. That is nothing but it is going to route to the node 2. Otherwise it will simply route to the node 3. Now, as usual, we will simply build our graph. So we will create an object of the state graph. We can simply import the state graph from langgraph.graph. In this, what we are going to do is we'll simply put it in the variable builder. This is nothing but the object of the state graph. And don't forget to add the state class that we have created over here. In this builder, we are going to add three nodes. That is the names of three nodes. You can see type node 1, status happy, status sad. These are the three nodes. First parameter is nothing but the name of the node. Second parameter is nothing but the function name where you have defined that particular node. Next, we'll add an edge. It will route from start to the first node, that is typed node 1. Next, it will simply go to the conditional edge. Next, once this particular typed node has got reached, after that it will be having a conditional edge. Now in this, we'll be having the very first parameter as nothing but the source from where the conditional edge is going to route. So it is going from type node 1, and it will go to further nodes based on this particular function where we have defined the logic. If the random value is lesser than 0.5, then it will route to the node 2, otherwise it will route to the node 3. So we just have put this particular random decision function in here as the second parameter. Next, we'll be defining the end edges. So basically, if it routes to the type node 2, then it will simply go to the end state. If it routes to the type node 3, then again it will go to the end state after execution. Next, we'll simply compile the graph and we are going to print the image of the particular graph. Let's print the image. Cool. Over here you can see we have got the graph as expected. First, the start node will go to the type node 1. Here, according to the conditional function that we have defined over here, it will route to any one of the node, and after that it will simply route to the end node. Now we'll try to check our graph how it works. So I'll simply create a new cell, and what I'll do is I'll simply invoke our graph with the initial state. So the initial state is that the username is Alice and the status is going to be unknown for at the initial stage, right? So over here you can see initially the user value will be Alice and the status value will be unknown. Now let's try to execute this and see what exactly happens. See, so basically it first routes to the type node 1, then goes to the type node 2. Now this routing is done based on this particular condition. The random value must have been lesser than zero point 0.5. That is why it has got diverted to the node 2. And since it has got diverted to the node 2, that is the status happy, its status has got changed to active, and you can see that particular thing over here. See, the status has got updated to active. So this simple state schema, I hope it is clear how we can simply define it, how we can update it. You can see, let me again give you an overview. We define it like this by extending to the typed dict, and then we update it simply as a dictionary. We return the node value as a dictionary, and we can simply update the values like this. That's it. It's as simple as that. I hope it is clear to you all. Now we'll move on to the next type of state schema that we have in LangGraph. So that is nothing but the data class. Now data class, it's an interesting type of state schema. First, let me tell you how you can import it. See, from data classes, we have to import the data class. This is nothing but a decorator. So we'll take the same example over here. You can see the graph also. We'll take the same example And since we already have the nodes defined earlier, now we'll simply change the very state definition. So instead of extending the typed dict, we'll now use this decorator. So I've created a class named my data class state. On top of this, you can see this decorator has got initiated. Now inside this, I have defined user with the type string and status with the type literal. You can define it as a string also. But just to make sure that we are going to have these two types in this particular variable, that is why I have written literal over here. In this, we have to mention the all the possible types that we can allow in this particular variable. And then I have created this particular node, the very first node where the initial thing will happen, like how we defined it for the first one, that is the type node 1. Now you can see in this particular stage we have returned the updates in the dictionary. And how we access the variable of the dictionary, we used it like state of with the with the square brackets and the key of that particular state, that is the user. Now over here in data class there is one single difference, is that instead of using the typical dictionary syntax, that is a square bracket and inside that you just mention the name of the key, instead of that you can simply use dot user. It's like using an object, it's like using a function from a class. So you can see everything is similar to the previous one, but the only change is that this print statement, and then we have we have simply returned the updates in a dictionary only. But to access the values of the state, we used state dot user. So this will get the value from the user variable that we have defined in our state. And then all other things are same as previous. We have created the graph and that's it. Now let me execute this. Cool. Now let's add a cell, and over here you can see I'm going to now check how it works. So you can see our initial state, how we defined earlier while invoking the graph, we have simply added on the dictionary syntax. It's like a simple Python dictionary where we have input as key value pairs. But here we have used the name of the class, and inside that, as a parameter to a function, we have passed on the name of the initial states, that is the username is Bob and the status is inactive. So this is the initial state. Now this status is going to change as per the conditional things that we have defined in here, right? If the random value is lesser, then it will go to the node 2, otherwise node 3. So like that. So let's check what we get. See, initially the status was inactive, then we invoked the graph, and then it has gone to the node 1, that is the data class node 1, and then it routes to node 2. Why? Because the status, why? Because the random value that it has picked was lesser than 0.5, that is why it has routed to the node 2. And since it has routed to the node 2, we already have defined the logic as it should convert the status to active. That's it. I hope everything is clear in here. We just have one simple difference. While accessing the state variable, we can use dot operator, and while invoking the graph or streaming the graph, we can use this particular syntax like this. That's it. So this is another way of defining the state schemas in LangGraph. I hope this is clear. Now we'll move on to the next type of state schema that we can have in LangGraph, and I would recommend you should have a practice to use this next state schema that we are going to discuss. And it is really important as well as interesting, and also it is it is based on standards. So the name of it is Pydantic. You must have heard about it. So we can define the state schema with the help of Pydantic also. Now, why Pydantic is very much famous as well as why it is important to use, because Pydantic by default comes with validation. So, as you know, Python, it basically checks the type of value that you put in the variable. If your variable is of the if your variable that you have created is only going to store integers, and if you try to pass a string in that particular variable, then Pydantic will restrict it from taking that particular string value. It will simply throw an error. The name of the error will be a validation error. Also, Pydantic is useful whenever you are actually trying to create a situation wherein you are deciding what all things can come in that particular variable. For example, you have only you have only 2 to 3 set of values that can come into the variable, and if a user tries to put another value to it, then it will simply deny taking that a and it will throw an error. So we'll see how we can define it. So basically, while defining the state, we have to write the name of the class, and we will extend the base model. So you can see base model, it is nothing but the base class for creating the Pydantic models. And how we can import this particular base class? We can simply import it with the help of Pydantic from Pydantic import base model. After that, we are also going to use the field validator as well as the validation error. So I hope it is clear how you can define the state with the help of Pydantic. So extend it with the base model, and the internal things are as it is: user status with the type string. Next, after defining whatever you want to define inside the state as variables, then you have to use this particular field validator. See, it's a decorator, field validator. Inside this, you have to put the name of the field that you want to validate. So the name of the field is status. So next comes the class method decorator, which will come on top of any function that you define to validate something. So basically, this validate status function, what it will do, it will simply check if we not in this particular set of values, that is active or inactive, that we already defined over here. It will simply raise a value error, that is nothing but status must be active or inactive. So it will strictly check whether the value of it is either of these two. If it is not, then it will raise this particular error. If it is either of these two, then it will simply return that particular value. So this is for the validation purpose, and Pydantic provides us this particular privilege to use. The method might look little bit complex if we look at it for the very first time, but it's very simple if you have a practice of it. Next, we'll define a node named Pydantic node 1. It's again the same. It's extending the state, and then over here you can see it is printing the Pydantic node 1, and over here while returning, we are simply updating the state, and for accessing the initial values we are using state dot user. That means the dot operator over here. And after that, we have simply used this particular simple builder things that we usually do to create any graph. And over here also we have used this particular conditional edge. Let's execute this. Now I'll simply try to invoke the graph. Over here you can see I have used the value of the user variable as Clara and the name of the status as inactive. Now since this particular status value is inactive, basically here the validation will be checked. Since it is either of these two, there won't be any error raised. Let's execute this. See, over here you can see it has routed to type node 2 because the value was lesser than zero point 0.5, and that is where the status has got updated to active. Now this is an ideal behavior of any type of state schema that you use. Now what if we try to invoke this particular graph with a value of the status which is not mentioned in whatever we have previously written over here, that is active or inactive? If it is not among these, then what will happen? Let's see, I've already created this particular try except block over here. I have tried to write the name of the user as Dave and the name of the status as unknown, but there is no restriction on the username, that is username can be anything, but the status name has to be either of inactive or active. But here we have passed on the status name as unknown, that is why it is simply going to throw an error. So that is why I have put it into the try block. If it throws any error, it will go to the except block and it will print the validation error. So let's execute this. See, we have got this particular validation error. Now why? Because the status has to be active or inactive. So this feature you get when you use Pydantic, it is very powerful and it comes very useful when you are on a production level applications. When you are going to deploy a production level application, it is really going to be useful. So I hope all the three types of state schema definitions are clear to you all, and this is an important topic. That is why I have discussed it over here. So I recommend you to simply practice these three types of state schemas and get your knowledge polished. I hope everything is clear. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. And for more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.